Welcome to Easy Maths. In this lesson, we're going to look at the concept of inverse variation. Now, this is contrasted with the concept of direct variation, so you need to check that particular lesson even before you look at this. Now, inverse variation occurs when an increase in variable results to a decrease in the other variable in a given formula, and this is exactly the opposite of what you said in direct variation. You can always check that video. Now, this means also a decrease in one variable results to an increase in the other variable. Now, to illustrate this, I'm going to consider the area of a rectangle. Now, normally, if we have a rectangle whose area is given 48, but we don't know what length it is or what width it is, or we say that the L and W are constantly changing, but the area is constant, which is 48, then you can say that A, or rather we know that A is equal to L times W. So area is normally length times width. And making L the sum of the formula, we're going to have A over W. That is, L is equal to A over W. Length should be the area divided by the width. A in this case is constant because it's a given figure. It's 48. However, we know that L and W are variables. Now, if that's the case, we can say that an increase in L results to a decrease in W and vice versa. That means if we want to maintain the area of the rectangles to the rectangle to be 48, but the length is constantly changing, or we have options of picking different values of L. If I pick a bigger value of L, I need to pick a smaller value of W, and vice versa. And the opposite also means that if I pick smaller values of L, I need to pick bigger values of W. And that's what this statement here means. Contrasting that with the concept of direct variation, say that increase in one variable results to an increase in the other. But this is the opposite of that. Increase in one causes a decrease in the other. A decrease in one causes an increase in the other. And so we can say that the variables are changing in opposite directions. One increasing, the other one decreasing. But in direct variation, in the previous lesson, we said that they move in the same direction. An increase in one causes an increase in the other. A decrease in one causes a decrease in the other. Let's consider two examples. The first one is this question here. We told, given that y varies inversely as x, and that y is 6 when x is 44. So find the equation connecting the two variables and the value of y when x is 2. Now, as we begin, we need to recall that when we are doing the question about direct variation, we had y, we had an equivalent of y, then this sign here, then a value here. This time around, we have y, the proportionality sign, then a reciprocal of the other variable. In other words, we have y varying inversely as, therefore it means 1 over. And so please notice that that other variable is a denominator, not a numerator like it was in the case of direct variation. So this is why you begin with the question. Then you move on to the next step where you just replace the proportionality sign with equal sign and k, like this y is equals to k over x. And moving on, since we're told that y is 6 when x is 44, just replace them there and you're going to get k is 264. Now, that being the case, we are being told to look for the equation connecting x and y, and therefore we're going to have to just write this equation again, only that k is going to be 264. And so replacing it there, you get the formula connecting the two of them, y is equal to 264 divided by x. Moving on to the value, or to question B, we're told find y when x is 2. So we have when x is 2, just replace it there, because x is the denominator there. The general formula connecting them is this one here, so you can get the corresponding value of y or x, so long as you have the other variable. So replacing there, you're going to get y is equal to 264 divided by 2. The other is 132, and we're done with that question. And that's how the question should be approached. Let's move on to another example. We're told the acceleration of a rocket varies inversely as the mass of the rocket if the propelling force is constant, given that the acceleration of the rocket is 20 meters per second squared when its mass is 40 tons. What is the acceleration when the mass of the rocket is 5 tons? Well, we need to identify the first thing here, the formula or general way the formula should begin. We are told acceleration varies inversely as mass. So I picked A for acceleration, M for mass. We know that mass must be inversely changing as acceleration. No wonder I have it that particular way. Then I replace the proportionality sign with equal sign and F. The reason is, in this particular case, in question 1, we replaced the proportionality sign with equal sign and K. But here we are told that F is constant. So since here we did not know the value of the constant, we picked K. But here we know what it is. So since it is F, since it is force, we pick letter F to represent that. Please notice that this part here is so much identical with this part here, because K over X is the same as F times 1 over M. So we would have F over M. Now we're told that given that the acceleration is 20, A is 20, when M is 40, so we need to find the value of F so that we know the general formula connecting A and M. So I put the values in the formula. I'm going to have 20 is equals to F times 1 over 40. Multiply both sides by 40, you get F is 800. And therefore, the general formula is actually A is equals to 800 over M. The question is, what's the acceleration when the mass is 5 tons? So I just need to replace the values. A is equals to F times a fifth. The fifth, 1 over 5 is 1 over M, where M is mass and it is in tons here. I also know that F is 800. So replacing the values there, you're going to get A is 800 times a fifth, which is simply 160 meters per second squared. And that is the answer for acceleration when the mass of the rocket is 5 tons. That brings me to the end of this second lesson on variation, dealing with inverse variation. Please check out for the next videos, which also build up the concept of formulas and variation. As always, please like, share, subscribe, and I'll appreciate it. Thank you.